Hello, hello. Glad to see you again on our Mobile People channel. My name is Sasha Denisov. I am one of the leaders of our global community of mobile developers. Today, we are going to talk with you about Flutter. And we have, I would say, a regular guest, Maxim Saplin. Hello, Maxim.
Hey there, Sasha.
Yeah. Maxim already visited us about a year ago, and at the time we talked about the advantages of Flutter and developing for many platforms at once. Yeah, if you missed this video, you can find it on our channel and watch it. Yeah. For those of you who who hear the first time, Maxim, please tell us a few words about yourself.
Yep, sure. My name is Maxim. I'm working as a delivery partner at EPAM. That's a managerial position, and my responsibility is working with a portfolio of projects, which gives me an opportunity to work with many teams and sometimes work hands-on. And this topic is the result of this one of these recent engagements. I started as a .NET dev back in 2008, did a lot of open source development, touched many UI frameworks. So yeah, I think I'll have something to tell about this subject.
Yeah, nice. Thank you so much. Yeah, today we will talk about Flutter again, yeah, as mentioned before, but we will talk about one interesting case about how to integrate Python code into Flutter application. But yeah, Maxim, could you tell me about a little bit more details about why such integration was needed at all? Because this doesn't seems like to be a very common case. For example, I wouldn't need such kind of integration at all.
Mhm. Well, I think one can speculate about someone else's reasons to do so. We had our own specific case, which I will tell you about in detail, and that was the natural choice, like build UI with Flutter and rely on Python for all the rest of the logic we needed.
Yeah, interesting. Yeah, I hope you will share more details during the talk and share as example how did you exactly do it. Yeah. So during the talk, please ask your questions. If you have, yeah, just type your question in the comments, and we will definitely answer all of them in the end of presentation. And of course, don't forget to like and subscribe to our channel if you like the content. Yeah, we have a lot of interesting things about mobile development here. So we can get started. Yeah, please, Max,
Yeah,
share your slides and let's go on.
yeah. By the way, my screen is visible. All is fine. I can proceed. Correct?
No. I don't see your screen. Could
Just
you share it
a
again?
second. Yeah. Okay, you should be able to see it now.
Yeah. Yeah. I see. Yeah. Here we are.
Oh,
So
okay.
I leave you alone. Yep, with your audience. Please enjoy, everyone. Yeah, and I will come back in the end, probably to help you answer questions or to ask your question. Yeah, a lot of options.
Okay, let me start my monologue. Unfortunately, I cannot hear you back, but still, there will be this question section. So I already told you a few words about who I am. Let me a bit explain what kind of relevant experience I have in the subjects. So first of all, I am an active Flutter contributor. I have plenty of GitHub repos in Dart and Flutter. Some of my projects are published to PubDev. which is a package manager, and one of the projects is quite popular, which is data table to widget library with several thousand users on GitHub, a few contributors besides myself. And besides, I did quite a lot of cross-platform app development. To the right, you can see screenshots from my Google Play. There are 3 apps. 2 at the top are built with Xamarin. They have not just Android, but other platforms. And the bottom up is a Flutter application built for 6 platforms. Yeah, so I've invested a lot of time and hopefully can share my experience. And speaking of Python, I didn't have a lot of experience. Frankly speaking, that was my first dive into this platform just recently. So yeah, the question, why Flutter and Python? One can imagine a million reasons, but let me just focus on a few facts. Python is the most popular programming language at the moment. You check different rankings, it will be either #1 or somewhere at the top. Python is very rich in terms of third parties. If you check PyPy, there are almost 500,000 packages of all kinds. And Python has the reputation of a solid development platform for backend, web, data, ML, and whatever. On the right side, we've got Flutter, which is #1 framework by Stack Overflow survey this year. It's above React Native, which is typically considered the close competitor to Flutter. It has almost 40,000 packages at PubDev, mostly revolving around building UI. And I might say that Flutter is the only cross-platform framework which supports Android, iOS, Windows, macOS, Linux, and web, with all 6 platforms being stable and supported by a single vendor. I doubt that you will find any other framework with such vast platform support. And speaking of Flutter, if we consider what are the other options for these right ones run everywhere frameworks, so we got React Native, already mentioned Xamarin, which is being phased out by multi-platform app UI MAUI by Microsoft. Also added to the mix Compose multi-platform from the creators of Kotlin. And here you can see a screenshot from Google Trends. And apparently, Flutter is the most popular by the number of search requests on Google. And by the way, Flutter is quite a young framework. The first version was released in 2018. It's probably the youngest, besides Compose multi-platform, in this stack. So essentially, if we're talking about Python and Flutter, there can be this natural synergy with Python being good at everything but the UI, and Flutter being a great, capable modern UI framework. And speaking of our specific case, like why did we end up with this mixture? So earlier this year, we had a new project where the client requested build a network scan tool, audit tool, which required some low-level DNS protocol capabilities. And the application was supposed to be packaged as standalone macOS and Windows desktop applications, and also be able to work in multi-user internet public setup with web client. Right away, we decided that we don't want to go native approach with 3 different profiles, like macOS, Windows, web. We wanted to utilize same skills for all 3 platforms. Besides Flutter, we also consider Electron, Qt, Flat. And by the way, there were no restrictions from the client, like what we should be using, like choose whatever you want as long as it works. And just a few words about other contenders. So Electron, that's a very well-known framework for building desktop apps. By the way, Visual Studio Code is built on top of Electron, but on the website you wouldn't find any mentions of web. And if you go web, then it's like you figure it out how you implement it. And there are not that many guides. well, Qt, we had lack of expertise in the company, like with people available and with desktop and web specifically. Flat, that's something we discovered at the beginning of the journey. It stated that it is a UI framework which lets you build Flutter apps with Python. We rejected it at the very beginning because frankly it was not what it promised. And we ended up with this mixture of Flutter being the UI framework and DNS Python, this third-party library doing all the low-level network stuff for us. Which is a very capable library. By the way, we didn't find anything in Dart, so that we could use Flutter for all the parts. And even in other languages, there were a few alternatives to this DNS Python library. And also on the go, we had two more requirements, kind of implicit. We didn't want to create macOS and Windows installers to prepare the machine for our application to run. We didn't want to be dependent on local Python. By the way, while on macOS it's installed, on Windows it's not. Okay, let's get started, and let me give you a simple example of how you can integrate, like the naive way of integrating Flutter and Python. For example, I have this Julia Py file which generates fractals. We can run it via command line just by passing the name of the file to Python3 command. Here we go, it's running. And essentially, we can do the same stuff by utilizing the process start from Dart.io in our Dart file. And what it does is simply says, hey, operating system, kick off this new process for me. And you can even see that our Dart code is able to communicate with this script. Again, that's a very naive approach. It uses this file to which the Python script constantly writes, and Dart script reads it. And frankly speaking, at this, I could stop and say that, hey, that's all you need to know about integrating Flutter and Python. That's how you do it. And actually, I've seen real production projects which use this naive approach. But there are many questions like, how do you serialize data? What is the communication protocol? Do you define your own calling conventions? How you install Python? And from my talks with the team which utilize this approach, they were not quite happy by simply running Python externally and communicating via text files. So probably that didn't work for us. So we did the research. If you Google the subject, you'll find quite a few links, a few questions that Stack Overflow, but the general problem is that many answers are open-ended, like use Flask, REST, JSON, and figure it out by yourself. Or examples just like I just showed you, run it externally, pass in the name of the file, and that's it. Then there was this flat, which said that it's the fastest way to do Flutter apps in Python. Though it turned out Flutter is hidden deep inside the framework. They created their own UI framework, which is very much inferior to what Flutter suggests. We also spent 1 week investigating a package called Python FFI, which presented quite, I'd say, well-described way of building Python scripts into Flutter. But there were a few problems, both with this specific package and the approach. First of all, there is this mention of pure Python module. By the way, that's just the list of adoptions which I researched, and none of those work for us. But speaking of this pure Python, if it happens that your Python project relies on dependencies with native components such as NumPy, TensorFlow, this pure Python requirement is not fulfilled, and you cannot use any integration option which relies only on pure Python modules. Second, the FFI, which is the shorthand for Foreign Function Interface, which is one of the options how Flutter can interoperate with native components. The problem with FFI is it doesn't give you any migration path to web. There is no FFI in web, and you will be recreating essentially web from scratch. FFI is executed in the UI, and if it's long running, then UI will hang, and you need to work around it by using isolates or whatever, like another extra piece of work. And frankly speaking, I'm not quite sure that out there are any FFI options for Python integration for Flutter at the moment. We didn't find any. So that's why we ended up with just putting together quite a few of well-maintained, well-known technologies. We added PyInstaller to work on the requirement of being not dependent on local Python installation, and we use GRPC for well, calling conventions, data formatting, and get rid of reinventing the wheel with this file communication. Well, if we look at this approach, the idea is quite simple. With GRPC, you've got proto-C files, proto-definitions, which define your APIs. Then there is gRPC provided tooling, which use these files to generate stubs and proxies in the language of interest. And gRPC has a wide support of different languages. So in our case, in order to use gRPC, we need to install the protocol buffer compiler proto-C. We need to install Dart plugin, proto-C plugin, and we need to install the Python package called gRPC.io. And with this, we are good to go. By simply pointing this command line tools to protocol files, we then get generated the stubs and services. That's where we can proceed and start implementing the services or consuming them via the client code. And PyInstaller, it allows us to take this whole project, build it as a autonomous executable, and we can put it into Flutter project as an asset. That's the general idea. Few words about gRPC and PyInstaller. So gRPC logically is composed of two blocks. The first is protocol buffers. That's the question of payloads. How do you serialize and deserialize data? And RPC, that's how you describe your services, procedures within those. And they work together as this open source, open standard framework. And if you research gRPC, you will actually find out that it's a very wide topic on its own, which is actually quite good because even if you don't need this complexity later on, you can rely on gRPC and say introduce discovery services, load balancing, or whatever. But the key notes for gRPC is that it's fast, it uses binary formats, and it relies on new HTTP2 protocol. And PyInstaller, that's probably the most popular solution that allows you to build standalone and still self-contained builds. It essentially packs the Python runtime and standard library, which is around 30 megabytes, together with the code, and produces this executable, which you can run as if it was just some console. And there are many other options and alternatives to PyInstaller. So, for example, I also tried NuVitka, which is a ahead-of-time compiler. But if you research, you'll probably find 5 more well-maintained, well-known alternatives with their goods and bads. And generalizing whatever we did in the project, I actually created this open source project called Flutter Python Starter Kit, which essentially brings quite a few bash scripts, which just help you set up all the dependencies, hides some of the complexity, and offers 3 deployment modes. Self-hosted, self-contained, that's when you can bundle your Python code as executable into Flutter app and then use localhost to communicate with it. It's working for macOS, Windows, and Linux. The second deployment option is remote. That's when this Python GRPC server is sitting somewhere remotely. The primary use is for mobile clients, but desktop clients can work it just fine as well. And the third deployment option is gRPC web. Web clients cannot communicate via HTTP2, and typically there should be a man in the middle web proxy, which translates the codes from HTTP1 and JSON format to binary HTTP calls to gRPC server. So all of this is included in this starter kit, which hopefully might save some time if someone has the challenge of integrating these tools. And by the way, there is this step-by-step guide which helps build from scratch a hello world Flutter Python application. But in our case, we'll be working on a more complex example, which is a fractal generator. So the idea is that our Python model will rely on NumPy and work with complex numbers and generate this so-called Julia set, which is related to Mandelbrot set. And like simply talking, fractals allow us to create this self-replicated repeating patterns, animate them, and you probably seen those somewhere already. And Python will be sending these frames like bitmaps, or not just bitmaps, but matrices with sets, and Flutter will color and render it. And also we will utilize gRPC streaming to animate and have Python doing it continuously. Few words about message exchange patterns. So the original implementation of gRPC supports 4. UniRPC is the simple request response kind of message exchange pattern. It also supports 3 kinds of streamings. In the web, there is only request response and server streaming. So in our example, we will be utilizing the 2 calling conventions, UNIRI and server streaming. Okay, let's have a look at the example project which I have built for you. Let's start by quickly looking at the structure of a solution. So we got our Flutter application sitting in the app folder. We've got our state generator, which is the Python implementation of our Julia streaming service. And we've got this essentially starting point, the definition of the service. So if we look at at this file, we can see that we define one service with 2 methods. The first method returns 1 frame. It's called height map. A few words why it's called height map. Like these fractal generators, they work on complex planes. Complex number is essentially 2 coordinates, and each pixel in our case is a complex number. And Mandelbrot or Julia set generators, they use so-called escape algorithm. For each pixel, it conducts a number of iterations before saying that, okay, it's our number or it's not. And we can count how many iterations we did for each pixel and use this information as a height map, and then use it to color it. So yeah, back to this definition. So we got this Julia set generator service with 2 methods which accept as a payload the request. The request consists four parameters. The first two are width and height in pixels. How many numbers do we want to check? Threshold, how many iterations per each pixel do we do? And position, that's allows us to animate and have different shapes of the frames. And the height map response returns the repeated int32 collection. Essentially, it returns a collection of width by height numbers, and also returns the last position it used to create this bytes. One remark: there are no multi-dimensional arrays in protocol buffers, so you should be dealing with one-dimensional bytes, which is not a problem, but like you will have to use a few extra steps. Okay, up is the Flutter application which consumes this service, and set generator is the Python server app which implements this service. Yeah, let's talk a bit about the starter kit that we have. So in a separate folder, there are two bash scripts. The first is called prepare sources. Let's quickly have a look at it. Well, essentially what it does is that it contains cross-platform Windows, Mac OS, Linux compatible scripts. And by the way, on Windows, just in case if you don't know, we can install Git for Windows and you will have Git bash. You can run the scripts on Windows without a problem. So what it does is essentially it prepares the machine installing all the required dependencies, such as protocol buffers, compilers, or whatsoever. It prepares separately Dart and Python dependencies that might be required, such as PyInstaller, and again, GRPC. It makes some changes in Flutter native projects. For example, by default, macOS applications run in sandbox environment. You should update some files to let it run external processes. Yeah, also it asks GRPC tool to generate the files for us, and also copies some of the helper files, which then come in handy when using all the generated files. So yeah, that's one of the files of the starter kit, and the second is bundle Python. What it does is it runs either PyInstaller or Nuitka, and then the produced executable is put to our Flutter application under assets. You can see it's already here, and also it updates the pub spec YAML to mention that, okay, please check that you've got something in this folder. Actually, you can read more about this, like what kind of problems this kit solves, how to use it, considerations, setting up, whatever. It's all described on GitHub. But just to give you the idea, there are quite many smaller things which, if you implemented it by yourself, I mean this bundle GRPC, Python, Flutter, such as how do you bundle it as an asset and extract? It's part of the Dart files copied. How do you manage the lifecycle of the process? Like how do you start and kill it? Again, that's something solved by this kit. How do you version the PyInstaller executable? Like what Yeah, but let's switch back to our plan. So yeah, let's probably look deeper into the folders created for us. Let's start with Python. So set generator, that's where our service implementation lives. GRPC generated folder was created for us by GRPC tooling, and you can see there are two files. PB2, that's about our payloads, protocol buffers. We will find our requests and response objects defined here. And GRPC, that's where we have the stubs for our service and methods. And these ones we utilize them, implementing actually this method. So as you can see, I'm importing these two generated files. I define a new class, and then I simply provide the bodies for these methods, which are essentially the methods from our protocol definition. Yeah, and besides, we have this actual logic implementing the like generation of this Julia set and returning it back. Another file which was copied by the starter kit called server.py. It relies on gRPC. No surprise, like if you look at the requirements.txt, you'll find that that's one of the dependencies, and gRPC team took care of creating this server which can start and listen for connections at the given port. And what we need is, as soon as the stub definitions are implemented, we simply add this service to the server and start it, and that's it. So this file I updated to include Julia set. These health services, they were already in the file, again, part of the starter kit. Let me quickly show you. Yeah. So, this health service, that's a standard service provided by gRPC team. It allows to health probe just to see if the server is up and running. It is useful when we are bundling the application with Flutter just to find out if it's started or not. Starting Python might be not fast. And let's quickly look at our Flutter application. So all of the work was done in the lib folder. That's is this write once, run everywhere feature of Flutter, like all of this Android, iOS, Linux, whatever folders they are created by the framework. All UI work is done in this lib and Dart files. And again, here is this gRPC generated folder with protocol buffer definitions of the requests now in Dart currently. The proxies which take care of communicating with the server. Again, everything is ready to be used. And quite a few files which I created and supply with the starter kit, such as client, which allows to communicate with gRPC in client agnostic way. Quick note, in Flutter, there are some distinctions when your code is running as a native app or in web. And Dart team provides two different implementations of client, gRPC web client if you're using the web client, and client channel and whatever it's called for native. And this part, it's called conditional imports. There's the feature of Flutter which allows you to substitute the implementations with web or non-web variants. And this client file, it's handy when you deal with 6 platforms. You don't care whether you're running in web or not. Another useful part is this init.py. That's again one of the pre-cooked files, which does the first of all initializes Python. It allows to extract some of the environment variables, such as which port you connect, whether to connect a local host to something else, whether to start the bundled service from the assets in the first place or not. And it also has two different versions for web and native. Native is bigger one because probably is dealing with assets. Yeah, so that's a quick overview of what we have. But let's now get started and start the application. And by the way, if you are developing in VS Code and working with Python, just make sure that you have the correct Python environment selected here. So, for example, if I check what my version is, it's 3.15. I've selected this one. If I choose different one, you'll get all kinds of issues with debugging, syntax highlighting, and whatever. Yeah, but back to running the application. I have created a number of different launch configurations. Let's start with Python. And as you can see, Python is already started. That's exactly the message that we have in our server py. And by the way, I'll just see if it works. As you can see, there is no hot reload in Python like in Flutter. If I add something and click save, it automatically gets applied. In Python, you need to explicitly reload the application. And let's start the UI. Luckily, we can start simultaneously two debugging sessions. And we can get the outputs from Flutter in the debug console and from Python in this terminal. Let's quickly try and see if we can hit breakpoints. Let's get this first attempt. And no, it didn't hit for some reason. Oh, that was different method, sorry. Yeah, as you can see, like if you launch separately the UI on Python, you can debug, and you can debug both at the same time, which is very useful. And I had this plan to tell you about VS Code configs. Essentially, if you're using VS Code, you can define all kinds of configurations, such as launch my app, don't care about the server, assume it's started. And this starter kit, it provides this arguments which can be used during build time, during run time, like, hey, don't use remote server, don't use local server. We might want to auto start for us, like if we are working only on the UI, we didn't change the Python part, we can launch it with the remote server and auto start in Python for us. And all kinds of different options. For the web, we can change the port and rely on GRPC web proxy. And by the way, speaking of the GRPC web proxy, as you can see, there are these pre-launch and post-debug tasks. If we look at what are those tasks, essentially we are starting the server, and we are also starting this gRPC web proxy. And by the way, let's right away try launching it in the web. So let's stop both of the debugging sessions. Let's choose Chrome. Let's pick web app auto start, and let's hit run. As we can see, this task it took care of starting the gRPC server. Also, it started the web proxy for us. And while it's starting, let me tell you what's about this gRPC web. Typically, you will be using Envoy proxy, but it requires Docker. There is also this very popular gRPC web Go implementation. You can simply download these console apps and run those as proxies. Okay, and here we can see that it's connected to localhost 8080, and we can try and get our first image. And here we go. Okay, but as you can see, it's very slow. Like, let me once again run it in the on macOS as a desktop app. And by the way, it can run this same UI will run on Android, iOS, Linux, whatever. You can trust me. You can try it by yourself. I tried it. It's all working fine. And let's start. And let's start server for us. And speaking of the performance, I have implemented this play animation button, which utilizes the second streaming. And you can see that each frame, even with this smaller screen, takes literally seconds. Like we've got 0.3 FPS now. Let's use this as a case to change Python part on the go and simulate as if we are working with real project, just doing something with our code. Okay, so there is this handy just-in-time compiler called Nomba. What it is a LLVM-based JIT, and you can simply put this decorator called njit on some of the methods, and if there are no unsupported features, Python features, then it should be a good starting point. So you remember that we had 3 seconds per frame with our original Python implementation, and that's just another example of how Python is really slow being interpreted language. And let's try it now. As you can see, now we are down to 60 milliseconds per frame and 10 frames per second on the UI with these minor fixes. We can actually go further. There is another feature which is called p-range, and we can simply remove at the top outermost loop in our generator, the p-range, and we should be good to go with even better performance. Let's start. Okay, as you can see, we are now down to tenths of milliseconds and to 16 FPS. But can we do better? Yes, we can. Let me quickly show you how. Let me pick another, yet again, our Flutter UI. Let's bring up CPU profiler from DevTools. And let's start the profiling session. At the same time, let's once again click on the animation and let's see what we've got in our CPU profiler. Okay, let's look at the CPU flame chart. And if you check that during those 8 seconds that we profiled, like most of the time was in this gRPC message conversion sync. What it means is that most of the time was wasted by Flutter by just moving around data, serializing, deserializing, and there is a huge performance improvement that we can get. And we will do this. Actually, let's once again revisit the protocol definition. My original implementation seemed that we use this repeated int32 response type, which was like the natural choice if you needed lists. But if you check the protocol buffers guide, you might find that there are no types which are smaller than 32-bit integer. On the other hand, there is this special type called bytes, which is essentially an alternative to blob with GRPC. So let's see how can we update our protocol definition and update like the whole stack, Python and Flutter. So I've got this pre-cooked protocol definition. Let me just copy it and paste. So what it does is that it creates this second kind of response, which replaces this height map from repeated int to bytes. And also it adds this third endpoint. And that's where we need to regenerate our protocol buffer and GRPC definitions. And for that, we have this script from the starter kit, which points to the protocol file, to the Flutter directory and Python directory. Let's run it. While it's running, let me quickly copy paste one more thing from here. Okay, it says that it's done, and let's quickly check. Okay, it generated nothing. Probably that's because I didn't press save. Yeah, I didn't save protocol buffer file. Let's rerun the generation. And let's check what we have in our folders. Yeah, now we can see that for us, we created Dart and Python parts. So the next step is going to Julia set and introducing this second method. Here we go. So essentially, that's the same method as above. The difference is that it returns different type of response, which we just defined, and it uses this 2 bytes instead of the list method from numpys in the array class. Okay, so we are done with the Python part, but we are not yet done with gRPC part in Dart. So what we need is to add yet another call to new endpoint. And by the way, in this file, I just abstracted away this communication with gRPC, but how you communicate to gRPC in Flutter is you create this client, you create this channel, which, by the way, is the one from the starter kit. You send in this generated for you payload, and you get the response. That's basically it. So yeah, back to our update. Let's check what we need to change in Julia service. Yeah, we need to add this part, I guess. Okay, and let's check if this helped us improve the performance of our application. First, let's run server py, and then let's run the remote server. give it a moment to start. Hopefully I didn't miss anything and will be green from the first attempt. And by the way, just to compare, I have these three radio buttons. The first is the original animation via int32 stream. Is it working? Yep, it's working. It's great. And now let's see if we have any difference with bytestream. Okay. Way better, almost 30 FPS. Okay, seems like we have fixed this, and what I've just demonstrated is how you update Proto-C and then have this update propagated to Python and Flutter parts. Oh, and by the way, just in case, I was curious to see whether Flutter and Dart can nudge the performance. My assumption was that like Flutter will be killing Python in terms of performance, and here is this Dart native implementation. And I was very much surprised when it was very slow, and at the same time, as you can see, it's freezing the UI because apparently all the work is done on the UI thread. So yeah, that's just an example that Python can be fast if you want to. Let me check what else I had. Okay, bundling asset. What I just showed you was essentially running server and app diff separately without any bundling. For this, like to bundle and to package our Python as self-contained, self-standalone application, we have another script. Here it is. What it does is, well, it generates the executable via PyInstaller. It puts it the right directory in Flutter. It updates the pub/spec YAML, and also it updates the version of the file that is bundled with the application. What I mean is that this GRPC generated folder has this py file info, and as soon as the bundling complete, we can see that this new version is updated so that whenever next time Flutter is started, it knows that, okay, I have new Python bundled with me. I should replace whatever I had before that. And let me probably try to run this bundled server for you. While it's building, let's check that we have this binary generated for us, and we have file info data for us as well. As you can see, our application is totally usable while the this Python part is loading, and it cannot connect. That demonstrates the problem with PyInstaller, that it can be really slow launching the application. Let's restart it once again. Can be like 20 seconds on a decent machines. There are ways to improve it, such as not use single file but the whole directory, but yeah, it is what it is. Let's wait once again. Hopefully this time, yeah, this time it started. As you can see, it launched the bundled server, and I think we should be good to run it now. Yeah, it's running, and now it's using this executable from the assets. Yeah, one last thing that I wanted to show, which might be useful when debugging gRPC. It's not just about this Flutter or Python stuff. It's basically can be helpful for any gRPC setup. There is this nice tool called Evans, which allows you to like test your gRPC server without writing your own client. So essentially, you can list whatever. Okay, something isn't working for me. Listen. Okay. Show package. Okay, so it's not working this time. Wouldn't be wasting your time, but trust me, that's a good tool which can let you test your gRPC server without writing your own client. I think that's it I had in my plan for showing this example, but a few words about this frames per second. I did test on a smaller screen, and those are some of the numbers of different configs. As you can see, Python with number, with p-range, with byte formatting, serializing was very, very fast. And few words about our project. So what we use is basically this approach. We built Windows and macOS standalone, and that is a remote. We use the AWS and Docker to host our backend, and we proxy to let the web client connect to the backend. Postgres as a database, GitHub Actions for GitHub. Some of the challenges like Flutter and Python, they're literally speaking different languages, and we required some time to get in tune, but eventually we received this cross-functional team and everyone could debug the whole solution on his or her box. Yeah, that's it. I think we are on time. Yep.
We are on time. We have 4 minutes till the planned end of presentation. Yeah. Thank you so much. It was really interesting. Yeah, probably I will take a look to the repository. Thank you for sharing. To touch it myself. Questions? Just don't hesitate. Type your questions, because we still have no questions probably. If people don't have questions, because everything is very, very clear for them, or I don't know. We'll see.
Okay, so if there are no questions, I think we can wrap it up.
Yeah, if there are no questions, but yeah, if you just watching us on YouTube now, not in the live translation, yeah, don't hesitate to ask your question in comments under the video. We are watching these comments and definitely will answer you when you ask us, or just you can find us somewhere. I mean, Twitter, LinkedIn. Yeah, and ask questions there. Thank you very much for your attention. Thank you, Maxim, for coming today.
Yeah.
And
nice
yeah,
talking, yeah.
Have a good day, everybody. Bye.
Goodbye.